you are making me to do, submitting the notes and all. As many number of assignments you are doing, you will be understanding the concepts.
Explain out.
Open the screen. Okay. So, good afternoon, everyone. Good afternoon.
Good afternoon, sir.
In the unit 1, we have seen so far what are the various topics we have seen. Can anyone say? What are the topics we have seen so far? Sorry? One line diagram, single line diagram of power transmission system. What are the various distribution systems we have seen? That is, the single line diagram will carry the generation, what is the voltage levels of generation, transmission, distribution, then to the end customer. That is, it will end up with service mains. It starts with generator, that is the power station, and it ends with service mains. Now, in this class, we will deal with the advantages of high voltage. Advantages of high voltage in transmission. Why we need a high voltage with some small derivation kind of thing. With some equations, we will justify that why high voltage is advantageous as far as transmission is concerned, right? And the second point, one is advantages of high voltage in transmission. And the second one is comparison of EHV-AC and HV-DC transmission. So these two topics will deal in today. The first one is advantages of high voltage So, during the introduction class, I told that the transmission has to be done in a high voltage. Done in high voltage, right? So, we have told certain advantages. Can you list something? Somebody? What is the advantage of having a high voltage for transmission instead of a low voltage, the normal voltage? There is the generation voltage is 11 kV or 33 kV, and the end customer is also utilizing 11 kV to 400 volts. That is during the secondary distribution, right? So why we have to increase the voltage, then step by step we are reducing it in transmission, right? What is the main reason behind it? To reduce the yes, I square R loss. Very good. The thing is, before that I would have told one thing. The current can be reduced by increasing the voltage for the same power flow, for the same amount of power to be carried. The current can be reduced by increasing the voltage. The thing is, P is equal to root 3 VL IL cos phi. This is the very famous equation of power. You would have studied in your circuit theory. So from this, what we can write is IL is equal to P divided by root 3 VL cos phi, or this can be written as P by root 3 V cos phi. So by increasing the voltage for the same amount of power, we are not changing the power, for the same amount of power to be transferred from one, there is a generating station, to the load center. I'll call it as load center, right? So by increasing the voltage, this current can be reduced. So we come to the losses. First one is reduction of, so I can write it as reduction of current. First point, the advantage of raising the voltage, that is having a high voltage in transmission, is reduction of current. And the second one is reduction of losses. So we know that loss W is equal to 3 into I square R. I square R is nothing but the power loss in a single conductor, since it is single phase. So since we have three phases, that is one line will have R as a resistance. If we have three lines in the transmission, we have 3 into R as a resistance. So 3 I square R is the total losses in the transmission. Now from this, W can be written as 3 into, this is my I. The expression for I is P divided by root 3 V cos phi. So 3 I square R, so 3 P square R divided by root 3, so we will be having 3 V square cos square phi. So this shows that, and this 3 gets cancelled, so we will be getting as W is equal to P square R divided by V square cos square phi. Keeping the power to be transmitted as constant, resistance is constant for a line, right? Cos square phi. What is cos phi? Cos phi is power factor. Power factor depends on what is the factor which will change the power factor? Sorry? Phase current. The magnitude of phase current, you mean to say? Phase angle. So the deviation between the voltage and the current. So that decides, that is fine, that is called power factor, which decides that value. What decides the value of power factor? Exactly, the type of load. If it is a resistive load, then you all know that, but you could not able to get it. Okay, fine. So as far as the load is concerned, it decides the power factor. So keeping the power to be transmitted and the type of load as constant, that is for the same amount of power to be flown, and say for transmitting the power to the same load. We'll take two cases, one is low voltage and the other one is the higher voltage. When we take that, power is constant, resistance of the line is constant, and cos square phi is constant. By increasing this, by increasing by 1 volt, the power loss, W is taken as the power loss. That power loss can be reduced to a maximum extent. Why means the voltage square is inversely proportional with the loss. The loss is reduced. If 1 voltage is raised, then the square of that is getting reduced. We will get an exponential decrease in power loss. Is it correct? So reduction of losses. Third one is reduction of copper required. What is this copper required? What is meant with this copper required? Can you give a guess? The amount of copper required is reduced by increasing the voltage. This is all we are talking about the first topic. Advantages of high voltage in transmission. By increasing the high voltage, these are some of the advantages. Okay. The volume of copper required for transmission. The volume of copper required for transmission. For transmission, we are going to use a conductor. Correct? So that conductor is made up of copper. Either it is aluminium or copper, whatever may be. So, as far as the copper required is concerned, we will take it as what is volume, area into length can be taken as volume of one conductor. Correct? Area of cross section into the length. That will give you the volume of a particular conductor. So, this 3 into A into L will give you the total volume required for a transmission system, since it carries 3 phases. Right? Now, from this equation, W is equal to P square divided by V square cos square phi. Instead of R, I am writing it as rho L by K. Since I need the volume, right? So this power loss can be written as P square by V square cos square phi. Instead of R, I am substituting it as rho L by A. That is the basic equation for a resistance in terms of its dimensions. Correct? So from this, A, I am taking P square rho L divided by W V square cos square phi. Can I write like this? I am just rearranging the equation. W is equal to P square R by V square cos square phi. That is what we have got. And from that, I have got A. So what we need is 3A into L. So substituting this A here, we will be getting 3. Instead of A, I am substituting P square rho L square. Here there is one L, and here we have got another L. So L square divided by W V square cos square phi. This is the amount of, that is volume of copper required for a transmission line. For the same power to be transmitted and for the same load, the length is fixed for the same distance. When we increase the voltage, the copper required is drastically reduced. Again, it is inversely proportional. That is, the square of the voltage is inversely proportional to the volume of copper required. Is it fine? Is there any doubt? And the fourth advantage, what we can claim as voltage regulation. We will have a better voltage regulation if we increase the voltage. I think I have discussed about this voltage regulation. What is meant by voltage regulation?